Well, welcome to my garage. I run my test bakers in here, although if we have a hot summer I'll have to move them somewhere a bit cooler. I've got two Macs there, one on GhostNet, I think one's on QuebecNet, and I've got a Raspberry Pi on one of the test networks there. I've got a development Linux machine up the top, and what I'm talking to you guys about today is these two machines. So I bought them on Amazon for 100 quid each. They have 16 gig of RAM, 256 gig of SSD hard disk. Today I'm going to install Debian Linux on one of them and turn it into a baker on the Quebec test network. There's nothing substantially different to running a baker on mainnet, so you can use all the principles that you learn here. You'll need to protect your key a bit better though, and we'll cover that a bit later on. And so the computer's already plugged into my network switch. I've got a monitor and I've got Debian Linux from their website. So let me just secure the camera and we will get going. Right, so I've broken into the BIOS and I'm going to boot from the USB stick. I've got no idea whether this will work. So look, yeah, it's already got a Debian install on this one, but I'm going to boot off the USB stick. Okay, there we are. Right, I'm going to use the text-based installer because I've just got a keyboard. And from memory, the first bit is configuring the keyboard. So I have a United Kingdom locale. I'm going to select all my locations. Obviously, if you have a different location, then select what you need. Now it's installing some of the basic components or loading them into memory. It's found my network interface and I can select that. It's getting its address from the router. It all seems to be working. I'm going to call this machine Terry, for want of a better name. I don't need a domain name for this. And it needs a temporary root password, so I'll just put something in that I can remember. Right, that needs to be confirmed. And now I'm setting an account up for me. I'm just going to use my standard account name that I've been using since 1997. Okay, and then just set initial password for that. All good so far. Right, now to partition the disks. So I'm not going to be clever today. I'm just going to use the entire disk and use one partition. And that's a 256 gig disk. That's the one I want. And all files in one partition. Looks good. So creating the file systems, and now it's installing the base system on the drive, so all the various packages that are essential to the installation. Great, that's finished. So let's configure the package manager. We're in the UK. I'm just going to use the top one, or I could pick any one. I don't have a proxy here. Downloading the catalogue. I'm going to opt out of the anonymous feedback. And here we are, some software to select. We don't need a desktop environment, I can take that out, but what I do need is an SSH server. And we'll want to log into the machine from elsewhere and take the monitor off. It's now installing the bootloader, which is the program that loads the operating system when you turn the machine on. It's just tidying everything up. We're nearly there. So the installation's complete. I can remove the USB stick and reboot. See what happens. Let's take that out. Hit continue. And the machine should reboot. In theory, I don't need to use the keyboard again. There's the bootloader. It's booted and I've got a prompt. So I'm going to retreat to the warmth of my office and continue from there. Back in a mo. Back in the office. So we're going to use a terminal program and an SSH client. So I use Macs and I use iTerm2. You can use what you want. There's a command line SSH client on the Mac, and there's many other options. If you're on Windows, you can use PuTTY, of course. So the first thing to do is try and find Terry on the network. My router supports dynamic names, and Terry has appeared as a record, which is great. I just need to see if I can log in to Terry with my usual login. Right, so all's good. We're ready to go. We're going to install the Octez software using the Debian packages provided by Nomadic Labs. The install guide is on their GitLab website. We aren't doing anything tasty, we're just following instructions. And the good news is the packages have got everything we need to get going. Now, firstly, I need to be root. And Debian doesn't install sudo or anything like that. So I need to use the root password, which I'll do now. I set that in the installation. I'm going to install a few prerequisites. So sudo is always useful to have. We're going to need GNU Privacy Guard, GPG, to import a crypto key to check the packages. And we're also going to need curl to download a few bits and pieces. So I can install all of those in one go using apt. Like so. Actually, what I forgot to do, and I'm going to do anyway, is force of habit. I'm going to update the catalogue of packages with apt update, and I'm just going to check that I'm up to date, which I am. So always a good thing to do when you start and get in the habit of updating your servers regularly. Okay, so now that's done, I'm going to add my account into the sudo group, and that will mean that my account can now sudo, and I probably need to log out to get that changed to work. So logged out, logged in again. There we are. That all works. So on the website here, the Tezos.gitlab, I'll put the links below the video. There's some instructions how to install the binaries. Now we're going to use these recently released packages. There's a little script here. It uses some variables. So if you type all these things in as they are, they will more or less work. You do have to be root for this first one to work, of course, but these other commands will work as a user that has got sudo access. So we've already done this one. I don't like using these variables, as everyone is aware. I make my my views known. So I'm going to type in these things more or less and try and get them right. So first thing we're going to do is we're going to get a link, which is a key, a PGP key, and that is used for signing the packages. So we're going to import that into our keyring. Done. The next one is to add a line to the bottom of this file. Now I'm going to ignore the instructions here and do it my way. Very Frank Sinatra thing to do. So I'm just going to edit the file and make sure I get it right, of course, which I probably won't. We are using Debian Bookworm downstairs, so this is the correct set of values. Good. Now I can. The instructions say use sudo. Of course, I'm root here already, so I'm just going to update the catalogue. And you'll notice now that the Nomadic Labs packages are in scope now, so I can download them. Right, great. All is good. So to install the Octez software, we're just going to use the apt command. I'm going to be very high level about this. I'm not going to explain every detail, but you should be able to get going if you follow the video. I'm going to install 4 pieces of software. We're only going to use 3 of them today. The Octez client is the command line wallet. We need it to set up a wallet for the baker. And you can manage a Tezos wallet with Octez client. You can do almost everything with it, actually. I think the only thing that I couldn't do is buy an NFT with it, because there's no way of connecting it to a web browser. The Octez node is the Tezos node implementation, and that's the thing that participates in the network. It stores the blockchain locally, does various other things, offers remote procedure call services, things like that. And the Octez baker is the actual baker, and this is the thing that will sign the blocks once we've set it up. We're not going to use the DAO package in this video. I'm going to do another video perhaps on that, maybe an article or something. Anyway, we can install all of the packages in one line as follows. So client, node, baker, DAO node. An apt will install any dependencies. So you see there's 2 dependencies there. One is a USB library, which I think is used for the ledger interface, and there's the EV4 library as well. And of course, because we've used an apt repository, when Nomadic Labs update these packages, you will be able to update them with apt upgrade -y to keep up to date. All good stuff. Right, looks like it's working. So whilst that's going on, these packages have configuration files. We'll have a quick look into the node one in a minute. There's one for the baker as well. These are not standard. These are things that we've added to these packages to make them more usable for new starters. So the node configuration simply has the user you want to run, user and group you want to run the node as. It has the node directory. This would be the standard one. So there's a user called Tezos that's installed as part of the packages, and they have a home directory via Tezos. So this is all standard. It's here so that you can move it around in one place. And we write our logs into var log Tezos. And there's a log called node log. The baker log we will come back to the Baker config we will come back to, but this is where we will put the key name that we bake with and the liquidity baking vote. They're the only two things you're likely to need to change. You won't need to change the node config either in most cases. Right, so because we are running the node as Tezos, we need to be the Tezos user to do some of the configuration. So we can switch to that user using SU. And we're going to join the Quebec test network. As I said before, there's nothing particularly different about joining mainnet or ghostnet. The principles are exactly the same. It will take you a bit longer, obviously. In a minute, we're going to download a snapshot. That will obviously take a lot longer on mainnet because it's a bigger snapshot. It'll take longer to import, but the principles are the same. So the node can be run in archive, full or rolling mode. Very high level explanation of that. Archive mode means the node will keep absolutely everything from the Genesis block up. Full mode will keep pretty much everything, but it will summarize the balances. So you won't be able to query an intermediate balance in history. And the rolling mode keeps just enough information so that the node can participate in the network. It keeps a bunch of cycles behind the current one. So rolling node is enough for us. We just want to bake. If you wanted to do some analysis of the data on the blockchain, you might be better off with an archive node or maybe a full node. But for today, we're going to use a rolling node. And with that, you can support operations from a wallet and you can bake. We're going to turn on the gossip port. That's the port 9732. And if my machine was on the internet or there was a path into that port, other nodes could query it and get information out on the gossip network. I'm on a NATed network, so it doesn't make much difference. I'm also going to set up RPC, which I said was remote procedure call, and that allows commands to be sent, requests to be sent, and that's needed to interact with wallets and the Baker. Good. Now, to configure the node, we use Octez node config init. And if you ever need to reset the config, you can replace the word init there with reset, and that will overwrite the config. So we need to specify the network. Now we do that with the network flag, and we're on a testnet, so we're going to use a URL which points to the test network. If you're on mainnet, you could just write mainnet there. If you're on ghostnet, you could just write ghostnet there, but all of the testnets are loaded, the configuration is loaded from a URL. We're going to use the rolling history mode. We're going to specify that we want to run our gossip port open. This is IPv6 notation for just to connect every interface and keep things open. And we're just going to run RPC on the local IP4 address because it's useful sometimes to be able to query your node locally. And that should be enough. However, today I'm going to tell you a little story. We're joining a very small test network, and as a result of that, we might not get enough connections for the node to think that it's sufficiently bootstrapped with information. So sometimes in a test network, you need to override the threshold of numbers of nodes that it thinks it needs to be sufficiently on the network. And we're going to set that number to 0. So I'm just going to add this one flag. You don't need to use this on mainnet. You shouldn't need to use it on ghostnet. And you shouldn't really need to use it on the smaller networks either. That hasn't rendered very well. Let's type that again. There we are, threshold equals 0. So that will help us get the node up quicker. So that's the configuration. I managed to type that correctly. We can look at the file. It's output. It's a JSON file. which is easy to read for the computer program, sort of easy to read, hard to edit for us. But you can see there I've got the rolling mode. There's a synchronization threshold. It's downloaded a lot of information from that URL. So they're the boot servers. They will answer to the node and give it its first bit of information to go and get the rest of the network. And then there's some information here about the DAO and also the Genesis parameters for the network. Now we could run this. Now we could run the node, and it would talk to the boot nodes, and it would start downloading the chain from Genesis. It would try and use all sorts of nodes if it could to do that. That's going to take us a bit of time. So what we're going to do is we're going to use a snapshot. So if I just move my terminal out of the way for a minute, we're going to use the Tezos Foundation's snapshot service, and we want a rolling Quebec snapshot. So we can come to this link here. And there's several ways to get the snapshot. We're going to use the most obvious one. We're going to use the HTTPS download. You can copy with G-Cloud storage. You can copy it straight onto your computer. If you're running in GCP, that's very useful. You can also fuse mount these GCS stores. So on a node, you can have the snapshots virtually on your machine at all times, which might be useful in an emergency. Also, then you don't have to download them. We've also got the Bake Buddy instructions there as well at the bottom. Right, so let's get this URL. I've started to download it, which was the wrong thing to do. Anyway, I want to download it here. So I'm going to get that URL. That will download to a file called rolling. And now I can import the snapshot. Rolling is the name of the file there. It's important you configure your node first. Otherwise, the default will think it's on mainnet and it will throw an error. So config the node first, get the snapshot. Now that's it. We can drop back to root, and now we can use system control to enable the Octez node service, and we'll run it by hand. Once you've run that enable, it will start on boot every time, and we have just started our node. Now let's see if we've got any logs. Well, log file is there, and it's generating its identity file. And there we are, it's up. It's starting the RPC server. It thinks it's synced, but that's only because we set that synchronization threshold low. Normally it would wait until it had caught up with the network before doing that. So now it's going to start to sync. And so I'm going to pause there for a minute and come back. The node is now syncing with the network, and we have a working node, which is great. So we can now set the baker up. And the baker needs a wallet, and it needs to have some funds in it, and we'll need to stake some of those funds. So firstly, let's generate a key. Now we drop into the Tezos account again. We can use Octez client like so to generate a key. We'll call it, what should we call it? Let's call it Chris key. Okay, and we can find that key now. There's my key. Now, word of warning. I'm running on a test network, so it's okay to have the key on disk. If someone were to hack this machine, they'd be able to take the key, but the key is only being used on the test network, and the coins on the test network aren't worth anything. If I use this key on mainnet, I'd need to protect it much better than this. Probably the best way to do that is to use a ledger, and I'm not going to cover that today. I might do another video on it, but I don't recommend using an on-disk key for mainnet, definitely not. Now we need some funds on the key. If we're running on mainnet, we'd obviously have to go and buy them or rely on a generous benefactor. But on Testnet, there is a faucet. So let's head over there and get some funds. So let's move him out of the way for a minute. The QBECnet faucet is here. I simply paste in the address. I request some funds. I'm going to take 12,000 Tez. Simply paste it in, click request. Now usually there's a proof of work a test there to slow people down so they're not hammering the faucet. I've turned that off on this site at the moment because I want people to join QBECnet easily. I will turn it on later on. Let's check that on the Block Explorer. So we come over here to the Block Explorer, the QBECnet one, and we can paste in the hash. And we can see there we've got the 12,000 Tez. Okay. So now we're going to register the key as a baker, or as it was formerly known, a delegate. So as in the Tezos account again, register key, I think it was Chris Key as delegate. Okay, so that's submitted an operation to the chain to register my key. We can see up here whether that's actually gone through. And there it is. So we've got a new baker. I've revealed my public key. And I've obviously spent a little bit of Tez to do that. Okay, now on a modern Tezos network, you've got to stake to bake. So let's choose the size of our security bond. I'm going to stake 10,000 Tez. That's submitted up to the chain. And we can see that here. So QBECnet is quite a fast network. We don't have to wait very long. The cycles are very short. And so we should be able to see some baking happening. I'll come back to that a bit later on, but we've got to prepare our baker on here. So first of all, we're going to come into the config and we are going to change the key name here to Chris Key and set the liquidity baking vote to pass. Now you don't have to understand what this is. It's safe to set that to pass for the purposes of this exercise, but if you're on mainnet, you might want to go and find out what this is and decide whether you want to vote yes or no or pass. But you have to vote something. So we're going to vote pass here. Okay, that's the baker configured. Then we just need to enable the service. And start it. And that's all there is to it. There'll be two new log files here, one for the baker. You can see that started to track the chain. It's connected to the node, all right. And one for the accuser, which is the software that detects bad behavior on the network and submits it to the chain. So now we have to wait. So I'm going to park this here for now, and I'll continue when we've got some baking rights, which won't be very long. Okay, so we're back and we've got some rights which we're checking on the Block Explorer here. So we've got some endorsement rights. These are actually attestation rights. The Block Explorer is using the old name. But in about 3 minutes we will be endorsing. So let's sit and wait for that. And this is the last bit. Once we see an attestation, we will know that we are baking. And there we jumped ahead a bit and we can see we're testing and we're injecting those operations onto the chain. So we have successfully set up a baker. We did that in 30-40 minutes. When all is said and done, it'd be a lot quicker if you've already got a Debian machine. But that's it. That's all there is to it. So I wish you all the best luck with your baking. You can find me on Twitter at Chris Pinnock. Please DM, keep in touch, and all the best. Have a good evening.